In this video, we're going to be looking at how to name and draw amines. So amines contain the functional group NH2, and you can see here is the functional group on this one. There is one carbon, so this would be methanamine. This one here, you can see here is the amine group. It's attached to 1, 2, 3 carbons. So this would be propan 2-amine. And here is the other amine group, because it's the most important group. It needs to be the lowest position. 2, 3, 4 with a branch which has got one carbon, so it's a methyl. So this would be butan 2-amine with a methyl group on carbon number 3. There are 3 different types of amines, and they're classified according to the number of alkyl groups attached to the nitrogen atoms. And those 3 are primary, secondary and tertiary amines. So a primary amine has one alkyl group attached to the nitrogen. So this would look like a primary amine. So we've got the N and we've got an alkyl group being the R and 2 hydrogens. A secondary amine has got 2 alkyl groups attached to the nitrogen. So secondary amines look like this with nitrogen, R, R dash, and 1 hydrogen. A tertiary amine has got 3 alkyl groups attached, and it looks a bit like this: N, R, R dash, R dash dash. So they can be anything, and they all have different physical and chemical properties. Here's an example of the 3 different types of amines. This one would be called methanamine or methylamine. This one here would, because it's got 1, 2 methyl groups, would be called dimethylamine. And this one here has got 1, 2, 3 groups, so this would be a trimethylamine. Now in our course is only going to look at primary amines only. So we're going to go through how to name primary amines and draw primary. If the amine is the main functional group present, then we need to find the longest chain containing the main functional group and put it at the lowest position. So 1, 2, 3, 4, 5. So this becomes pentan 2-amine. It has another functional group, a chloro, which is less important, and that goes to prefix, and it is 4. If there's a more important functional group than an amine, such as an alcohol or a carboxylic acid or an ester, then the amine goes to prefix, and its prefix is amino. So in this particular example, we have an amine group, we have a bromo group, and we have the alcohol group. Now the alcohol is the most important functional group present, so it needs to be in the lowest position on the longest chain. So 1, 2, 3, 4, 5. So this is pentan 2-ol. Now we have an amino functional group in prefix and a bromo functional group in prefix. Because once they're in prefix, we go to alphabetical. So this will be amino and bromo. So bromo and then amino. And we need to put the address, which is 2 bromo and 4 amino. Now what I'd like you to do is to try and name these primary amines. You will need to stop and start the video. So in this particular amine, here is the most important functional group. It needs to be in the lowest position. 1, 2, 3, 4, 5. So it's pent, tan, 2, amine. Let's try the next one. Stop the video. Okay, so we have an amine group, an alcohol group, 1, 2, 3, 4, 5. We also have a branch, which is a methyl, because there's 1 carbon in it. So this is pent, tan, 2-ol. And we have a methyl, which is located on carbon number 3. And we have an amino, which is located on carbon number 4. Try the next one. Stop the video. So now we have a look and we can see that this is the most important functional group. So this is a type of an amino acid because we've got an amine group and a carboxylic acid group. The carboxylic acid is on the lowest position, which means that we also have a methyl group. So this is propanoic acid. Because there are 3 carbons, we have a methyl group. And that can only be found on 1 location, location 2. And we have an amino group. So 3 amino, 2 methyl, propanoic acid. Now we're going to draw some primary amine. So the first thing is to draw the parent chain. Add any functional groups to the appropriate carbon. Add the functional, any substituent alkyl groups and any functional groups that are in prefix. So the parent chain is propanoic acid. So 1, 2, 3. 1, 2, 3. On carbon number 2 we have a hydroxy group. On carbon number 2 we have a chloro group. And on carbon number 3 we have an amino group. Now I'd like you to try some examples. Stop the video so that you can try drawing them. So bute means 4. 1, 2, 3, 4. And means they're all single bonded. And on carbon number 2 we have an amino group. Now put on the appropriate number of hydrogens. So each carbon has 4 bonds. Next we have 1 amino prop is 3 carbons and means single bonded. 2-ol means alcohol group and 1 amino. Now put the appropriate number of hydrogens on, so each carbon has 4 bonds. This one, butanoic acid, so bute 1, 2, 3, 4 and means single bonded oic acid. Then on carbon number 3, 1, 2, 3 we have an alcohol group. On carbon number 2 we have an amino group, so this is an alpha amino acid. And then on carbon number 4 we have another amino group. Now put the appropriate number of hydrogens so each carbon has 4 bonds. I'd like you to go to the OneNote, Organic Amines and Amides, and do the nomenclature exercise on amines. Good luck.